we're going to visualize the process of how while loops work in C. First, I want to show you the code that we're going to review, while.c. And this is what has been presented. We are going to initialize an integer as 0, and while it's less than or equal to 10, we're going to print out its location using %p, and we correlate, just to review, we correlate the output specifier with the address using ampersand of the variable. Here we print it out as an integer, and here we print it out with its hexadecimal representation. A couple quick things when we compile this is that the register is going to be the same the entire time, but it's going to start out at 0, and the hex is going to be 0. And then once we get to 10, you're going to notice that it's going to be 10, but that's going to change to A. So we're reviewing several concepts while actually bringing in this new while loop concept. So what is going on here? How do while loops work? Well, let's take a look at this example. We have a long integer where it's equal to 4, and it goes while I is less than 6. So the first thing is that the code will actually check to see whether we meet the condition. 4 is less than 6, so it evaluates true. It's going to print out that the value of I is 4 and the hex value is 4, and then it's going to increment I++. It's really important that you ensure that the condition has a terminal case, meaning that there needs to be a way in which this is guaranteed to stop. If we left this code out, the compiler wouldn't catch it and it would just go forever. So we don't want that to happen. What we're going to do is we are going to ensure that we have those kind of cases, and we have that in this example as well as in the while.c code. But we go back here. 5 is less than 6, so again it evaluates to true. Again, we print out the values, and then we increment. And then we reach 6 is less than 6. Since 6 is not less than 6, it evaluates false, which means that we are not going to execute this code. And it's going to go down here and it's going to print out fprintf. We skip it and we conclude. So now let's take a look at how this will work. It's going to go from 0 to 10, but there's a last stage in which the int is going to be 11. And I'm going to prove this by making a slight modification to the code. So I press I, and I'm going to use fprintf standard out, the int equals %d, and I'm going to say the int. So I match the variable to the output specifier, and what's going to happen is it's going to print all of these from 0 to 10, including 10 because we have less than or equals, but you're going to note that we still increment this. So it makes it here as an 11. And this is something that's going to help you as you work on your own algorithms on when you should choose for loops or while loops and how everything works from there. So I'm going to right quit this, and now I'm going to say gcc wall, and I'm going to say while.c, create the object and the executable, and we're going to call that while. And so it compiles. Now I'm going to run the executable, and we see that first and foremost, every single time, all of these values that indicate the address of the register are the same. The reason why is because when we allocate the register, it's always going to be at this physical location, which we're going to simplify here as 91C, since those are the last 3 bytes. And that value inside changes. So initially it's 1, 0, then it's 1, then it's 2, and so on. Now, what happens in that while loop is that it gets to 10, and then we go back to the while loop, and since it's less than or equal to, we are going to go inside and print that out. And that's what's happening here, this printout. But notice that the last location is plus plus. We increment it again, so when we get to the while loop, it's going to say 11 is less than or equal to 10. That is false, and therefore we terminate the while loop. But bear in mind, there is a physical data in the computer that's still there that is incremented because we do that loop every single time, which is why the int prints out as 11.